Hello, everybody. I am Roland Nemmer. I'm in the online marketing team at TÜV Süd in Germany, and I'm really happy to welcome you today for our Digital Dialogues event. You ask, our experts answer. And today's webinar is on testing in accordance with the IEC 6061-1 series for active medical devices. But before we start, here is some organizational information to you. As we have only 30 minutes for the webinar, unfortunately, we cannot answer your individual questions in this session. But if you have any question, we will be happy to answer them in the individual one-to-one meetings with our experts. To take part in a one-to-one meeting, please register on our event website. For the further inquiries, you can also contact us by email at digital-dialogues@tuvsud.com. Please note that after the webinar, the presentation will be shared to you by email. At the end of the webinar, we will publish a link to a survey, which only takes a few minutes of your time. And we are really grateful if you could give us a brief feedback, which helps us to improve the services and adapt them to your personal needs. So now we won't waste valuable time, and I will give the mic to our expert, Dr. Tobias Beck, and enjoy the webinar today.
Thank you very much, Roland, for the introduction. Welcome to all of you to this webinar today with the content 601-1 testing for active medical devices. My name is Tobias Beck, and I'm the department manager in Munich Test Lab for active medical devices, and my team takes care about the testing with the complete 601-1 family. On this slide, you can find my contact details, and I would be very happy if you would like to contact us or myself in order to have to clarify further questions. You can find the website, email, and LinkedIn address here. Now, for the next 30 minutes, I would like to give you an update about what happens in the area of the 601-1 testing. I have, let's say, 5 topics where I would like to talk about. First is to have a quick look at the requirements of the regulations or the directives in Europe. The second one would be to give you an overview on the 601-1 family with its standards, different standards. Then in the middle of the presentation, I will go into the details of the changes which we had with the Amendment 2, which came up now in August this year. Then I would like to talk about transition periods, which is quite important when we have new standards to understand until when they have to be implemented. And last but not least, I would like to give you an insight into the discussion which is going on with respect to single fault safety of medical electrical equipment related to essential performance, which we also call functional safety. So let's start with the requirements of the regulations and the directive. As most of you will know, we have the situation that we have a change in the regulation. The NDR is now relevant for manufacturers, and both the medical device directive and the regulation, they address, let's say, specific characteristics of medical devices, and they want to define requirements in order to make these medical devices safe. Now, for the medical device directive, the details are documented in Annex 1 in the essential requirements. And when we have a look at these electrical, mechanical issues, we find more details in Section 12, where it says the device must be designed and manufactured in such a way as to avoid, as far as possible, the risk of accidental electrical shocks during normal use and in single fault condition. A very similar statement we can find for mechanical risks. These requirements are quite similar also in the medical device regulation, where the Annex 1 is called General Safety and Performance Requirements. And you can find here a very, very similar wording. So there is not so much new with respect to these, let's say, safety things. But the regulations and the directive, they are quite general in their requirements. And therefore, most manufacturers, they apply standards in order to comply with these requirements. And for active medical devices, let's say the most relevant standard, which is applicable almost to all devices, is the 601-1, where we have now the latest edition, Amendment 2, which came out in August this year. Together with this basic standard, we have the so-called collateral standards, which are where the number is 6061-1-XX, where, for instance, specific requirements for alarms or for, let's say, medical devices used in home healthcare environment are documented. And in addition, the third part of this family are the so-called particular standards, the particular requirements for specific products. They are documented in the IEC ISO 60601-2-something. So, for instance, a dialysis machine or infusion pump, they have specific requirements which are documented in these particular standards. Now, an important question is what happens, what you as a manufacturer or we as a test lab or a notified body, what we all have to do when the standards which are applied, when they are changed, when they are revised. So the point is that we consider the newly published standards, IEC or ISO standards, as state of the art. So, and together with the state of the art changes, we have a grace period of 3 years. And this applies even if the standard is not harmonized under a directive or a regulation. So only the fact that the new standard, the new international standard is published changes the state of the art, and thus has to be considered by the manufacturer. So with this new state of the art, the manufacturers have to think about whether new requirements have to be tested or evaluated. And so the new test requirements, new testing needs can be triggered not only by the medical device regulation, by a change in the regulation, but also by a change in the standards. Now, let's have a look at the 601-1 family. Here you can see an overview about the complete family, and it looks a little bit confusing at the first view. In the center, we have the so-called general standard 6601, and around this general standard, we have different regulations, different standards, different guidances, as you can see. We already talked a little bit about the so-called collateral standards, which you can find here. They overrule in certain parts the general standard 6601, or we would have particular safety standards, the so-called Part 2 standards, which also can overrule 6601-1 general standards. But in addition, we have also, let's say, guidances, the so-called technical reports. They are an informative guide. They try to explain a little bit more in detail how the 6601 standard has to be read. And they are only, let's say, as an information. They are not mandatory to be applied. And so this total, let's say, complex family has to be considered. You have to look at this in order to define the specific requirements then for your medical device. In the left part here, you can see a little bit the history of this 6601-1 family. It started all in 1977. Then we got let's say, a big change with the third edition about 15 years ago. And the latest revisions were in 2012 with Amendment 1. And now, as already explained, the Amendment 2, which came up some months ago. It is planned to, the next big change is planned for 2025, where the fourth edition is going to come up. Good. Now I would like to go a little bit more into details in the changes which came up with Amendment 2. In total, we have around 78 changes together with this amendment. This is not so much when we compare it with Amendment 1, where we had 490 changes. So it's only a smaller change, and let's say the most important needs to update the standard were included into this Amendment 2, and the others were transposed to the fourth edition, which will come up then later. It has been published, as already mentioned, in August 2020, and let's say the correct spelling of the standard is documented here. You can see it's the basic standard plus the Amendment 1 plus the Amendment 2 from 2020. And in order to make it a little bit easier, we also refer to this standard publication as edition 3.2. Please note that the Amendment 2 has a big impact on you as a manufacturer, since also many references have been changed. A little bit more impact it has on the manufacturers compared to test labs. And be aware that products which compared already, which confirm with Amendment 1 at the moment, they do not automatically comply also with Amendment 2, since we have in fact some new requirements, some changes. And each and every one of these changes have to be considered and evaluated. In order to do so, to understand in detail the changes, sometimes it's helpful to use the so-called red line version of the standard, where you can see the difference between the old revision edition 3 and the newest revisions with Amendment 1 and 2. So it's easier to understand what really has changed. Good, so let's start with the first change, which seems to be important to us. It's about labeling. In the Amendment 1, we had a reference to that symbol, the blue symbol with the man having the book, reading the book, which gives, let's say, the operator the need, or which tells him to read the user manual, the accompanying documents. In Amendment 2, this requirement has been, let's say, clarified a little bit. It says when the accompanying documents are used as a risk control measure, and in addition to this, a sign is needed to make this measure effective. This sign is to be used here. So it makes let's say, a reference also to the usability file and to the risk management file a little bit more clear. In clause 7.2.9, it's about the labeling for the IPX. For the IPX classification. In Amendment 2, now it was clarified that we do not need a marking for IPXX, which is not specified, for IPOO, for IPXO, and for IPOX. Also, an important change has been done to clause 7.8.1 and table 2 within this clause. This change is about let's say, the document, the coloring of lights. So in the past, we had let's say, a very small table 2, which gave us information about the colors of indicator lights. And in fact, this small table did not fully comply with the requirements of the alarm standard -1-8. So they changed it. They changed this table, and the idea was to document the requirements now in compliance with the alarm standard. For instance, you can see now that we have two columns here. One still is called the indicator light, but we have also another one which is called alarm indicator light. And you can see now a clear, let's say, difference between which color and which light has to be used when we just want to make an indication, and what is the difference then to make an alarm statement. So this table now, let's say, does create less problems when -1-8 is used in combination with the basic standard. And yeah, the requirements of the two standards, they now match much better together. Clause 8.4.2 is about accessible parts and applied parts. And here the Amendment 2 requires the requirements here have been extended to SIP-SOP connectors. SIP-SOP is signal input output parts. So let's say a USB connector or others are meant by this SIP-SOP wording. And in addition to separate power supply output connectors. The test method has been defined to determine the voltage at the connector, to use a 10 kilo ohm resistor. And it now says if this voltage, which is measured, is less or equal to 60 volt DC or 42 volt AC, a subsequent leakage current test is not necessary, is not needed. However, if the voltage is above this limit, then the touch current from the SIP-SOP connectors to the earth and from other separate power supply output connectors shall be measured. So this is much more clear now how to handle this part. When we have a look at the patient protection, also there were some changes. First, we now talk about optocouplers, where we have a clear reference now in the Amendment 2 that optocouplers shall comply with IEC 6747-5-5. And when they comply with these requirements, they also comply then with the requirements of the basic standard of the 6061-1, and especially with respect to air clearance, cleavage distance, and dielectric strength test. A new reference now, which has been implemented for Amendment 2, is about the standard 62368-1. This is about IT equipment. In Amendment 1, this was still not referenced, this standard, and we only had a reference for 6950. So IT equipment formally could only be used when it complied with 6950 in the past. In the edition, we can use 6950 equipment and also 62368 equipment. An important thing is that when you use 6950 equipment, mostly let's say the means of operator protection, the two means of operator protection, which are included in the power supply with 6950, is identical to can be used as one means of patient protection. This applies for voltages, working voltages below 500 volts. For power supply with 62368, this is a little bit different, and the voltage is lower. So only when the working voltage is below 250 volt, then this applies that the two means of operator protection complies or is identical, can be used as one means of patient protection. When it's above this voltage, then it's not necessarily identical, and you have to draw attention to air clearance or high voltage test. So be careful when you use a power supply having a certificate of 62368, and have a close look whether you can use it as a means of patient protection or not. Now, we talked already about the working voltage. Also here we have a clarification in clause 8.5.4. We have now a clear methodology defined how to measure this. You have a drawing here, circuit, where to connect and how to measure this voltage. So also now with this change, we expect to have more clear results for the working voltage. And another one is about conductive coatings, which is new in clause 8.9.1.16. It says that manufacturer they have to consider conductive surface coating of plastic enclosures in order to confirm that flaking or peeling does not result in a reduction of creepage and clearance distances. So when something would happen, as you can see here in the picture, this could result in less creepage or clearance, and this has to be addressed by the manufacturer and has to be considered. In clause 13.1.2, it's about temperatures. In the past, in Amendment 1, there was only one table talking about accessible parts. In Amendment 2, now we have separated this, so we have two tables. The first table, 23, is now about accessible parts likely to be touched, and they usually have to be touched in order to operate the device. And in contrary, we have table 34, which is also about accessible parts likely to be touched, but usually it's not intended to touch these parts. So we have now a difference between the temperature limits. And when we have a look, for instance, for molded material plastics, in table 23, we have a limit of 86 degrees C, and in table 34, we have a limit of 104 degrees C. So this gives a little bit more, let's say, reflects a little bit more the reality where we have had in the past sometimes higher temperatures, and they are now allowed, let's say, for parts which are not intended to be touched. So let's have a quick look also at the collaterals which have been changed. Happily, let's say all of these collaterals are already updated, are available in a new edition. So this makes it much easier for you as a manufacturer and for us as a test lab or as a notified body to evaluate this, makes it less chaotic, let's say. So we tried to classify a little bit the changes of the collaterals into 3 groups. We have the group where only editorial changes came up, and in this group we can find the -1-9, which is about environmental requirements, and -1-12, which talks about emergency environment. We have minor changes here in this column, where we have the -1-2 EMC. We will have later on in this webinar also a presentation about this standard and also the changes. We have the usability -1-6 and the home healthcare environment -1-11 with minor changes. And we have major changes for 2 standards, for 2 collateral standards only. This is the alarm standard -1-8 and the physiological closed loop controller -1-10. Due to time reasons, I cannot go into details now. Just giving you this slide as an overview. For -1-8, you can find the major changes here, and for -1-10, the physiological closed loop controllers, you can find it on the right-hand side. Later on, you will get all these slides, and you can have by yourself a closer look on this. Let's also have a look on the references which were updated in the Amendment 2. So basically all of the references which were, let's say, not longer up to date were updated. You can find also an overview on this table. Here we have the references of Amendment 1, and here you can find the references of Amendment 2. And you can see that for risk management, the reference to software development, to usability, lasers, IT equipment, which I mentioned before, and also secondary lithium batteries has been updated. And the correct reference can be found now in this table. Good. Now let's go to the transition periods, which is also an important issue when we talk about changes in the standard world. Basically, the standard committee recommends a mandatory implementation nationally not earlier than 3 years from the date of application. So the committee itself is aware that you cannot, let's say, include these new changes from one day to another, that the manufacturers need a little bit of time, and they recommend 3 years. However, the application of standards, as you all know, is voluntary. It's not required by the regulations, and therefore it depends a little bit always on the regulatory scheme where you on the market where you want to place your product on, how this is handled, how the transfer is handled of new standards. In Europe, we can say the following, that at the moment, we still do not have harmonized standards in an official journal under the MDR as we had in the past under the MDD. This for sure would help and has helped us a lot in the past, since it clarified the situation until when an old standard revision can still be used and since when a new standard needs to be implemented. However, as already mentioned, newly published standard, they have to be taken into account since they became state of the art. Let's say a general approach here, which was done in the past and which is well accepted for IEC test reports, is a transition period of 3 years. So we expect that most of the manufacturers will have updated their records by the end of 2023. So the implementation, let's say, into their design process will start now, I assume. However, since it will take a while until the product is finally developed and can be placed on the market, this takes several years, and therefore the expectation is end of 2023 to have all the documents, all the technical documentation updated, including standard test reports of Amendment 2. Now let's have a quick look on the particular standards, how to handle this. As already mentioned, many devices, they have particular standards, and in the best case, these particular standards, they shall be applied together with the basic standard, since they sometimes modify some sections of the basic standard, some requirements, they overrule requirements, and therefore it's also always helpful to use these both parts together. The standard committee expects that all particular standards will be transferred by the respective committees within 2 years. So within 2 years, we expect to having an Amendment 2 edition of the particular standards. If the respective committees will not do so, then IEC said that they will transfer these particular standards in a formal way in order to make them usable in combination with the basic standard Amendment 2. So until then, what should we do until we have all the Part 2 standards transferred? For Europe, we think it's reasonable that you use the basic standard of Amendment 2, although the particular standard has not been transferred so far. This is what we think it would be reasonable. As already mentioned, let's say the combination of certain standards, etc., is not mandatory, and therefore we think that's a good idea for Europe. For CB, unfortunately, this combination is not possible. The CB scheme of IECE has strict rules, strict requirements, and we cannot, let's say, combine certain issues of the standards together. So at the moment, we cannot issue a CB certificate when the particular standard has not been transferred. And I included here a note which is not longer valid. I wrote here that the IEC TRF is not available. That's not correct anymore. I received this morning the information that it has been published on the IEC webpage now. So testing against this standard can be started by the international test labs right now. Good. Last but not least, I would like to give you an insight into the single fault safety issue of medical devices relating to essential performance. Some general aspects at the beginning. For a medical device, as you know, as a manufacturer, basic safety alone is not sufficient for a product. So we have also for sure a so-called essential performance, which is basically a clinical function. And this essential performance must be valid in normal condition, in single fault condition, and also when simultaneous failures occur under certain conditions. So in theory, we sometimes call this single fault condition for essential performance functional safety, although this term is defined in 61508, which is not applicable for medical devices. We took this term as well for, let's say, this aspect. The regulations try to address this as well. It is not so easy since, let's say, the regulations cannot so specifically define requirements. It is mentioned in the new medical device regulations, since it says notified bodies, they have to have personnel which are qualified for the assessment for functional safety. So let's say the authorities, they became aware of that this is an important issue and try to implement this. However, as with all the other requirements, this is more general. And when we want to go into more detail, then we need to apply standards. And therefore, for sure, we have to have a look at the 601-1 family. And here it says that medical electrical equipment have to be safe to essential performance in single fault conditions. This is said by the standard. However, at the moment, it doesn't. The 601-1 basic standard does not give any details how to perform the tests. That's a little bit a pity at the moment. Some Part 2 standards, they do so. For instance, the dialysis machine standard, there we have defined requirements how such a single fault safety with respect to essential performance have to be implemented. However, this is not for all Part 2 standards. The standard committee, they has noted this, let's say, gap, and the ad hoc group 34 has worked on the issue in the past, and they addressed it by a 3-step approach. They have now, let's say, published, or it will be published now in November, an interpretation sheet, how to handle this issue. They want to publish a technical report in step 2, and step 3 will be the 4th edition of the standard, which then wants to include all these requirements, which we will see in a few seconds. Be aware that the work of this ad hoc group, that this does not have an impact on the safety philosophy of the 601-1 family. It just gives a little bit clarification on how to handle it, how to use it. So let's have a look at this interpretation sheet, which is quite helpful according to my understanding in order to clarify the requirements. basically we have two clarifications. One is about essential performance and the other one about single fault condition. As I mentioned, we have no new requirements. This is just a clarification. And thus it says with respect to essential performance, or normal condition as well as single fault condition have to be considered with respect to essential performance. Essential performance is defined in terms of the performance of a clinical function. So here we have the link with the clinical function. And it says as well, the single fault condition can cause or contribute to the loss or degradation of such a clinical function. And it also defines or clarifies the interpretation sheet that the manufacturer has the following requirements, has to do the following. The manufacturer has to identify this performance of clinical functions. And the manufacturer has to specify performance limits. And these limits have to be defined for a normal condition and for a single fault condition. The manufacturer has to evaluate the risk when we have a loss or degradation of these functions. They have to implement risk control measures, determine which risk control measure needs verification, and specify also methods for this verification. So a lot of, let's say, more or less clear requirements with respect to the manufacturer. The results of this assessment have to be documented. And the compliance statement, this is then important for a test lab, refers to the inspection of the risk management file, and inspection means careful examination or scrutiny of the contents of the risk management file. So the test labs, they have to have a close look at these documents which are published by the manufacturer with respect to this single fault condition of essential performance. Now also let's have a very short look on the clarification on the single fault condition. It applies to both basic safety and essential performance. Single fault condition means we have a defective or a single abnormal condition in present. When the initial failure remains undetected, we need to have a second failure, which then can be detected. The risk analysis is used to determine which single fault conditions are to be tested. So that this should be an outcome of the risk management file to have the details of what to test. And again, the documentation has to be done by the manufacturer, intended to serve as objective evidence. So these, let's say, these parts in this interpretation sheet give a little bit more information for you as a manufacturer, as well as for notified bodies and test labs, how to handle this part. As already mentioned, we have further steps of this working group, of this ad hoc group, which I would like to show you here. A technical report has been recommended by the working group, which may be published by the end of 2022. This technical report, if you remember in this overview of the regulatory schemes, of the standard schemes, is voluntary, but in certain regulatory schemes it is mandatory. It has to be applied as well. This is not the case for Europe. And step number 3 would be this 4th edition of the 601-1 family, where all this information which is collected by now and which then will end up first in the technical report, where all this information will be then transferred to edition 4. And I would like to cite here the working group saying the way how to verify that essential performance is maintained in fault condition should be improved in the 4th edition, including ways to test and document it. So this is, let's say, the hope of at least of us as TUV, that we have here more clear requirements how to address this issue. Target date, as mentioned, is 2025, 2026 for this edition 4 of 6061-1. Okay, with this slide, I come to the end of my presentation. I hope that you have received some insights into what's going on at the moment on this discussion. I would like to draw your attention to the upcoming live events which we have. Today we have an additional for EMC. Tomorrow we will then have MDR, and the day after tomorrow we will have a lot of interesting talks about IVDR. If you have further questions to myself or the other colleagues, please register yourself for these one-to-one meetings where you have the chance to talk directly to the experts. And I think that's quite helpful when some questions will be left. Thank you very much for your attention, and I wish you a nice day.